Hey everyone, and welcome back. Today, we've got a really fantastic YouTube explainer lined up for you right here at CodeJoy Academy. We are going to completely demystify the foundational data types you need to launch your programming journey. Because honestly, whether you're just writing a tiny script to automate your morning routine, or you're building some massive complex web application, literally everything you do in Python boils down to the concepts we're about to cover right now. So, let's get into it.
So let's just jump right in with a pretty fundamental question. How does Python actually see the world? I mean, when you or I look at a word or a number on a screen, we instantly know what it means. But a computer? It doesn't understand things the way a human does. It needs really specific, rigid structures to interpret, store, and manipulate that information. If we don't understand how Python categorizes data, well, we simply can't write effective code.
You can kind of think of data types like different shapes and sizes of Lego bricks. Just like you wouldn't try to use a tiny, flat little tile when you really need a massive structural pillar, you need to use the right data type for the right task in your code. They are the absolute foundational building blocks for every single program you will ever construct. And the cool part is, once you understand the bricks, you can build absolutely anything. To give you a quick roadmap, here is your stealth toolkit for today. We're going to start with the primitives, which are your basic numbers and text. Then, we'll look at collections to group those things together. After that, we'll get into typecasting, which is basically shape-shifting your data, and finally, mutability, so you know exactly what's permanent versus what is modifiable. All right, starting off with Section 1, numbers, text, and truths. These are our core building blocks. We're going to examine the simplest, most fundamental primitive bricks first, which usually represent the kind of data you'd interact with in real life, like basic math and language. So in Python, we essentially have three distinct numeric types. First up is the int, or integer. What's actually incredible about Python integers is that they have unlimited precision. Seriously, they can be as long as you need them to be, constrained literally only by your computer's memory. Then we have the float, which handles all of our decimal numbers. Behind the scenes, these are stored as base 2 fractions. And, for the math and science enthusiasts out there, Python also natively supports complex numbers, complete with real and imaginary parts. But to put things into perspective with floats, check out this absolutely massive number, 1.8 times 10 to the power of 308. Because floats use a 64-bit double precision format under the hood, this represents the absolute maximum size a float can be. If you try to calculate a number even slightly larger than this, Python basically just throws its hands up and calls it infinity. It's a really good reminder that while our digital tools are super powerful, they do still have physical limits. Okay, moving away from math and over to language. When we're dealing with text, Python uses what we call string objects, or str for short. You can think of a string as just a sequence of characters wrapped up in quotes. And because they're built on sequences of Unicode code points, Python strings can handle practically any character or symbol from any human language. That makes your code globally adaptable right out of the gate, which is pretty awesome. Now, this next concept is absolutely crucial. It's how Python evaluates truth. In Python, every single object has a built-in truth value, meaning it's considered either truthy or falsy. The constants none and false, those are falsy. Any mathematical zero, falsy. And any completely empty container, like an empty string or an empty list, is also falsy. But get this, almost everything else in Python evaluates to truth. Understanding this gives you an incredibly powerful shortcut when you're writing logic to check if a container actually has data in it. Okay, I absolutely love this part. Here is a super fun, kind of surprising Easter egg. The Boolean values of true and false are actually just a subclass of the integer data type. That means, under the hood, true and false are secretly just the integers 1 and 0 wearing a trench coat. You can literally mathematically add true plus true in Python, and the result will spit out the integer 2. How cool is that? Moving right along to Section 2, collections and mappings. Now that we know what our basic primitive bricks look like, let's explore how we actually organize them. Because, let's face it, you're rarely working with just one single number at a time. Usually, you're managing entire datasets. And these right here are your master builder tools. First, you have lists, which are your go-to ordered sequences. You can throw anything into a list and it'll happily maintain that order. Then you have dictionaries, which are incredibly fast mapping collections. Think of them like a real-world dictionary. You have a unique key or a label that points directly to a specific value. Sets are perfect when you need a collection where every single item must be absolutely unique, no duplicates allowed. And finally, tuples. They're a lot like lists, but they are totally fixed. Once you create a tuple, its sequence is locked in place permanently. Which brings us to Section 3, the art of typecasting. Just when you thought you had all your building blocks figured out, we get to introduce a little programming magic, changing their shape entirely. This is how your code becomes dynamic and actually adapts to different kinds of input.
We call this shape-shifting process type conversion, or typecasting. Now, Python is actually pretty smart about this. It does a lot of implicit conversion automatically behind the scenes. For instance, if you add an integer and a float together, Python just automatically turns the result into a float, so you don't lose any of your decimal data. But sometimes Python needs you to take the wheel. And that's explicit conversion, where you manually force the data to change its type using built-in functions.
Let's walk through exactly what that looks like. Imagine you have a user typing their age into a form on your website. When that comes into Python, it's just a string literal. Literally just a text characters 1 and 2. Well, you can't do math on text, so you melt it down using the built-in int function. You pass the string in, and Python casts it into a usable mathematical integer. Voila! Now Python sees the actual number 12, and you can calculate whatever you need to. All right, we've reached Section 4, mutable versus immutable types. This is the master architect's secret. For the final climax of this explainer, we really need to unpack this concept because it is the most critical architectural philosophy in Python memory management. It trips up a ton of beginners, but once you master it, your coding skills will instantly level up. So let's define mutability. Remember earlier when we said everything in Python is an object, and every object has its own unique identity in your computer's memory? Well, mutability dictates whether an object's internal data can be actively modified on the fly while keeping that exact same memory identity, or if it's permanently superglued together the exact moment it's created. And this creates a massive divide in Python. On one side, we have mutable types, your lists, dictionaries, and sets. You can actively modify these in place. You can add items, remove them, shuffle them around. It's great for dynamic data. But on the flip side, we have immutable types. Strings, tuples, and all of your numbers. They exist in a permanently locked state. If you want to change an immutable object, you literally can't. You actually have to throw out the old brick and tell Python to build a completely new one in a totally different spot in memory. Knowing this one rule will save you from so many incredibly frustrating bugs down the line. So, now that you've got this rock-solid grasp of the Master Builder toolkit, everything from your primitive numbers and strings all the way to dynamic collections and the golden rules of mutability, I want to leave you with one final question to spark your next coding adventure. How do you plan to combine these new data types in your very next CodeJoy project? Think about how using truthiness could simplify your logic, or maybe how grabbing a tuple instead of a list could protect your data from accidental changes. The possibilities are entirely in your hands. Thanks for watching, happy coding, and keep building.